Hi everyone, so today we're going to talk about the question 7 on the 2015 A-Level P3 Maths paper. So this is one of my favorite topics. It's vectors, and we are given 3 points which have position vectors OA, OB and OC respectively. And let's read the question in its entirety. Well, first they tell us to find the plane M is perpendicular to AB, okay, and contains the point C. So immediately we know a point on the plane and we know the normal to the plane because it's AB. So we're told to find a vector equation for the line passing through A and B. So that seems simple enough. Then obtain the equation of the plane M, giving your answer in the form ax plus by plus cz equals d. Okay, so they want it in that form. And then we're told that the line through A and B, so the line we found in part 1, intersects the plane M, of which we found the equation in part 2, at the point N. Okay, and find the position vector of N and show that the distance Cn is root of 13. Okay, let's get started, and I'll explain the topic as I go along. So the equation of a line is given through A and B will be given by this: R equals OA plus lambda AB, where lambda is some scalar. And that's because you can imagine a line which looks like this. So that's your line, and let's say it has a direction like this, which is AB. There we go. And the origin could be at some point here, so 0, 0, 0, which is here. So, and this is point A, and let's say that this is point B. Actually, let's put point B a bit in the middle of the line. Oops, the line is gone. So there we go. We have the line here, and let's say this is point B on the line. So then we can go to point A like this, OA, and let me reposition point B. Right. So that's point B here. Okay, so we go to point A first, so by OA, and then we go lambda in the direction of AB. So any lambda in the direction of AB. So that's why we have this equation, which is here, and using that, we get exactly this, which then when simplified gives this. Okay, and if you don't understand why AB is OB minus OA, well, you can draw a Cartesian plane, say, in 2 dimensions, and say, well, this is point A, which is given by OA. This is point B, which is given by OB. And how do you get AB? Well, AB is the vector joining A and B from A to B, so that's AB. Well, AB is found by first going to A, right, then going to B. So AB must then be equal to OB minus OA. Because if you add OB minus OA plus OA, you get back OB. So there we go. That was an aside, but this is your equation of your line. And that's very simple, and lambda is some scalar, which essentially when you change lambda, you change the point that you reach on the line. So lambda equals 1 brings you to B, and lambda equals anything in the real numbers brings you to the whole line. And we call that the line parameterized by lambda. Okay, so question 2, tells us to find the equation of the plane M, which contains point C and is perpendicular to AB. So we already know AB, which is that. So AB equals 2 minus 2, 1. Oops, there we go. So how do we find the equation of a plane? Well, here I drew a schematic of a plane, and R is a general point on the plane. So R is a general point on the plane, and it can represent any point of a plane like this, right? So this could also be R, or this one could also be R. And N is a vector which is perpendicular to the plane. Okay, so then in general, the equation of a plane can be written as R dotted with N, and I put this hat on top of the N, which is here. The hat signifies that N is a unit vector, similar to here. So N hat is unit vector. So then O dot N hat is P, is a general equation for my plane, and it gives me the distance of the plane from the origin. And to see where this comes from, let me repeat the drawing of a plane and explain it. So we have this plane here, right? Let's say we have a general point here, which is R, and we have this. So this is our normal N. So what is the distance from the origin? Sorry, this is the origin 0, 0, 0. What is the distance? So this distance right here, this is P. Well, the distance is given by P equals to, and let's say this angle is alpha, well, it's pretty clear that it's R. Let me draw the vector. So it's R cos of alpha. Well, to R cos of alpha, I can say N hat, because N hat has magnitude of 1. So this term is 1. Right? But this is exactly the definition of a dot product, and you can see my video on the dot product where I emphasize this. So this is R dotted with N hat. So in general, this will hold true for any point on the plane. And that's why this is the equation of a plane, right here. Right? So let's use this. Well, R is some general point of a plane, but we have AB. So AB is not a unit vector, but then we can modify this equation right here to obtain this equation. So multiply by some constant, and let's change the name of a constant here. Let's change the name of a constant to some constant C. Right? So this part of the equation is as follows, because we just multiplied both sides by C. But then you have to realize then that this is, oh, let me not use C because C is already used in the question, sorry. Let me use a Greek letter, let me use phi, right? So O dot phi n must be phi p, and this is obtained from this equation here, multiplying both sides by phi, where phi is a scalar. So this equals to a new something which I shall call D, but this D has to hold for the point C, right? So the point C, in particular, if I take OC dotted with AB, I should obtain D, because C lies on the plane. C lies on plane. So it has to satisfy this equation. So then we're done, because R is any point XYZ on the plane, dotted with phi n, which is nothing but AB, and this equals OC dotted with AB, which comes out to be 4 if you do the math. Right? So then you just do the dot product and you obtain the answer. So that's quite straightforward. The general point I want you to take away from this is how do you find the equation of a plane, and this comes out directly from the dot product, which is explained here. Yep. Okay, so that's a very easy question, and you could do that in an instant. So now we're told that N lies on the plane and also lies on the line A and B. Sorry, the line through AB, through A and B. Okay, so how do we do this? Well, we're told everything we need. We're told that N lies on the plane n lies on the line. Well, how do we use this? Well, we've just seen that every point that lies on the plane has to satisfy this equation. Right? And also every point which lies on the line has to satisfy this equation for some lambda, and n will satisfy the equation for one value of lambda, which I denoted by lambda n. So I replace, and then I solve for lambda n. So in particular, I get this equation for lambda n, and then I put this into the first equation, so the equation of plane, and this gives me this equation for lambda n. When I solve this equation for lambda n, I get lambda n equals 2/3, which tells me that ON is 1 to 0, so that's OA, and then I go 2/3 in the direction of AB. So essentially, what I've done is say that if I have a line here through point A through point B, then N would lie somewhere here. So this is 2/3 of the way. This would be 1/3 of the way. And 2/3 of AB, of course, and 1/3 of AB. Right? And this right here would be AB. Right. Okay, so that's simple enough. Now that we have ON, we can find CN, which is the distance which is required. And this is just some simple Pythagoras theorem. So you do the math and you end up with root of 13, which is shown here. Another thing which I wanted to say about vectors while I'm on the topic is that you will sometimes see the formula which tells you that distance from origin, if you are given an equation of a form like this, well, you can break this into x, y, z, dotted with a, b, and c, and this equals d, right? So this brings us back to the equation R dotted with phi n, where n is a unit vector, equals d. And R is any point on the plane, the position vector of any point on the plane. Well, the distance is then simply d divided by a squared plus b squared plus c squared. And that's really easy to see, right? This is the distance from origin. And why do I say this? Well, we know that R dotted, sorry, let me write this underneath so that it's clearer for your notes. Well, R dotted with n equals to p, where this is the distance from origin. But p is nothing but d over phi. And phi is nothing but root of a squared plus b squared plus c squared. So this finishes our proof that d over root of a squared b plus b squared plus c squared gives us the distance from the origin. Alright, that's it.